Okay, we will start on chapter 4. Chapter 4 is primarily known for its concentration on logarithms. Okay, chapter 4 is not known to be one of the easier chapters. It's not that there's the quantity of material like there was in chapter 1 when you were just burdened down with tons and tons of material. The thing about chapter 4 is that it's got logarithms in it. And basically, I have found over my many years of teaching that many of you are weak on logarithms. So sorry about that. Logarithms are a presence throughout the world and that you just should really know something about. And it's unfortunate that some of you have backgrounds in logarithms that is not especially strong, and you may struggle a bit on the logarithms. But we're going to be also doing some power functions here and some other kind of interesting things with investing money. And chapter 4 is a very interesting chapter. By the way, after we're done with chapter 4, all we have to do to complete this course is chapter 6, portions of chapter 6. All right, so we're going to start with power functions. Okay, start with power functions. You see power functions in a lot of different applications, from growth, as in money, to decay in radioactive substances. We'll be talking about both. Here's purchases of smartphones, illustrate a growth function that has a power function involved. You can see back in the early 2000s, there were people, millions of people with iPhones, smartphones, but not very many. Starting here in 2008, you can see it's only 1.7 million, then all of a sudden it takes off incredibly. And it's up to 35 million within like 4 or 5 years. So that is an illustration of a power function. Here's another one involving decay with methylchloroform. Some substances decay or dissipate as a gas, and this shows you the dissipation here in the quantity as it goes out and separates itself from the body. That is an exponential decay. Okay, it starts off really decaying quickly and then starts to slow up. Both examples of power functions. So let's look at a power function. A power function is written a to the x, where a is some number. So I'm going to pick the number 3. I could have picked any number. There's nothing special about 3. Let's find a variety of these. F of 2 would be 3 squared, or 9. F of 1/2. If you remember, when you raise a number to a fraction, okay, it's a root, and the bottom of the fraction is always whether it's a square root, cube root, or whatever. Because it's a 2, 3 to the 1/2 would be the square root of 3, or 1.73 to the square root of 3. F of 0, any number to the 0 power is 1. F of -2. Negative exponents, remember, flip. So 3 squared is 9, but you flip it to the bottom and it's 1/9. So 3 to the -2 is 1/9. F of -1/2. Well, we know 3 to the 1/2 power is the square root of 3, okay? So when you flip it, it would be 1 over the square root of 3, or 1 divided by the square root of 3, and I get about 0.577, okay? So that is an illustration of what functional values are with 3 to the x, a power function. And here is the graph of 3 to the x. As you put in negatives, because they flip, remember, 3 squared is 9, but 3 to the -2 is 1/9. They get smaller and smaller and smaller and smaller, and they get asymptotic, it's called, when it gets so close to the x-axis, but never touches. But as x gets bigger, it explodes upward, just like the sales of smartphones. All of your power functions will do this. All of your power functions will do this, okay? They will cross at 1, they'll explode upward, and they get closer and closer to the x-axis. You should, by understanding that, you should be able to manipulate various graphs and you should be able to tell where a variety of graphs will be located. For instance, here's exactly what I was talking about. Here is your basic y equals 3 to the x function. What about when you put a negative sign just on the x? Remember this from chapter 2, I think it was? When you put it just on the x, doesn't it flip it left and right? So this red curve would come down this way, hit at 1, and you still get asymptotic to the x, but in the positive direction. Another way of understanding that, these are all negative x values. When you put a negative sign in front of negative x values, they become positive, okay? And so whenever you have all these negative numbers, they should react the same as the positive side does, and that's why it goes up. Negative 3 to the x. When you put the negative sign in front of the function, it doesn't flip it left and right, like when you put it on the x. But when you put it on the whole function, all of these positive values are going to become negative. They're going to flip down over the x-axis, still asymptotic to the x-axis, hits at -1, and goes down. How about a -1 just on the x? Remember that? A -1 just on the x means that it moves it left or right, and if you remember, it should be the opposite of the sign. So a -1 is going to move this function over 1 unit. So it's going to still explode upward. It's going to come down through this point and then still get asymptotic to the x-axis, okay? But how about if your +1 is +1 on the function? The whole function is +1, moved up 1. This 1 will go to 2. It's still going to explode upward, but then it's going to come down and be asymptotic to y equals 1? Yeah? Yeah? How about this one? What would e to the x plus 4 minus 2 look like? All right, so let's sketch that. Now, am I doing big enough so that you can read what I'm doing? Yeah, it looks pretty good. Okay, so here we have your basic e to the x is a power function. It's going to come down like this, right through here, and get asymptotic to the x-axis. What we want to do is put a +4 only on the x and a -2 on the whole function. A +4 only on the x will move it horizontally. 1, 2, 3, 4. So this one would come down. I'm just going to sketch it this way. This one would come down and hit here, up 1. Okay? So do it this way, just as a, and then it gets asymptotic to the x-axis. But the -2 then moves everything down 2. So this one is still asymptotic to the x-axis out here. But when it goes down 2, it's no longer going to hit at 1 right here. It's going to come down 1 here and down 1 here. Okay? So it's going to explode upward like this. Okay? Then it's going to get asymptotic to y equals -2. Okay? Instead of still being asymptotic to the x-axis, you move it down to, this is at 1, down 1, then it'll get asymptotic and explode upward. You should be comfortable in doing that, and I think most of you actually are. Okay, so let's talk about power functions and what we can do with power functions. A fruit fly colony has 100 flies initially. The population doubles every hour. Find the function. So we know initially at time t equal to 0, there's 100. At t equal to 1, there's 200. At t equal to 2, there's 400. It doubles every time. T equal to 3 is 800. Okay? Can we write a function from this? And once again, am I writing big enough so that you can, yeah, you can read that. Okay. Well, we know it's because it doubles. 2 cubed is 8, 2 squared is 4, 2 to the first is 2. So I should be able to make use of that. I think my function will be f of t. We need to take 2 to a power. So if we take 2 to the t power, like at 1 hour, 2 to the first is 2, then take it times 100. In 2 hours, 2 squared is 4 times 100, 400. In 3 hours, 2 cubed is 8 times 100 is 800. Okay? So there's your function, 100, 2 to the t. All right, now let's talk about money. You said, what in the world? What's money got to do with pre-calculus? Ah, I'm glad you asked, because now we're going to find out. What's the worth of $1,000 at 8% annual percentage rate? APR means annual percentage rate. That will almost always, in fact, I think it will always be given to you in the problem, 8%. If you are just compounding your interest after 1 year, you're compounding it one time, you simply take 0.08 times 8,000, and I think you get 80 bucks. So after 1 year, your $1,000 is going to become $1,080. Okay, compounding interest. Okay, if you could compound the interest more often than just once a year, then the interest that you earn throughout the year would also be earning interest, and you could make more money than 1,080. Okay, and that's what we're going to talk about here. What if we wanted to compound it quarterly? Which means we're going to have to do it 4 times. A quarter is every 3 months. All right, so we must do it 4 times in that year. And I've got it kind of spelled out here. Don't bother writing all this down. I just want you to see if you can follow with me and observe a pattern. All right, follow with me. See if you can figure out the pattern. At the end of 3 months, quarter 1, you would not take the 1,000 times 0.08. It's only for a quarter. You got to divide by 4. You take it times 0.02. 1,000 times 0.02 is 20 bucks. You add it on and you get 1,020. But I want to write it a little bit differently. What we did was we took $1,000 times 0.20 and we added it on to 1,000 to get the 1,020, right? But look at this. $1,000 plus 1,000 times 0.20. You can factor out the 1,000 and get 1,000 times 1 plus 0.02 to also get the 1020. So just kind of hold that thought. All right. Now go to quarter 2. This time we're up to 1020. You would take 1020 times 0.02 and add it on to 1020, right? But notice there's a 1020 both places. You can take, and we're going to get 1040, 10. That's what you get when you do the math. But now notice there's a 1020 both places. So I can yank the 1020 out. And I still have, when you take it out of both parts, you still have a 1 plus 0.02 left. But hold everything. What was 1020? Wasn't 1020 this? So if you take this and put it in there for that, you see it? And for that, you're going to have 2 of those. So you have 1,000 times 1 plus 0.02 squared. Okay, still with me? Now, we said when we did all this in quarter 2, it makes 10, 40, 10. So at the end of quarter 3, you take the 10, 40, 10 times 0.02 and add it on to the 10, 40, 10. And you get 10, 60, 121. Okay? Or if you look at it another way, there's a 10, 40, 10 in both of these. Factor it out. And look what you're left with, a 1 here, a 0.02 there. But wait, what was 10, 40, 10? Was it not 1,000 times 1 plus 0.02 squared? So if you put 1,000 times one of those squared times another one of those, you're going to get 1,000 times one of those cubed after 3 quarters. Are you seeing the pattern? Okay. It appears as though, let's talk about the pattern. You have a starting amount of money. We'll call it P0. Starting amount of money. You're going to take 1 plus whatever the interest rate was, let's call that a letter I, we divided by 4 here to get the 0.02. So you want to divide by how many times you're compounding interest. Quarterly is 4. Yeah? So if it's monthly, you divide by 12. If it was semi-annual, you divide by 2. If it's weekly, you divide by 52. Yeah, you with me? So here, we want to divide by the number of times you compound interest. Okay, so that's M. Then you want to raise it to 1, 2, 3. That was the total number of quarters, right? The first quarter, the second quarter, okay? So now this is a 4, all right? That'll give us quarters, but we don't want it to be 4 every time. Like the first time is only 1/4 of a year. So if I take it times the number of years, the first time through, now follow with me on this. This is a 4. The first time through, this is a 1/4 of a year the first time through. So 4 times a quarter is, we just did it 1 time, and that's what we got, 1 there. The second time through, it's still 4, but the second time through is half of a year. Half, 4 times a half is 2. And that's what we got up there. Are you with me? This is the formula. This is the number of years. Okay? This you will need to know. Okay? This is when you're compounding interest more often than just once a year. You can do it monthly, weekly, as I said, daily, whatever. Let's finish this problem now. And how could we see what it's going to cost to get it for the 4th quarter? Okay. You could take the 1061, we could do it this way. You could take the 1061.21. We could take that times 0.02, get our answer, and add it to the 1061.21. And I get 1082.43. Now remember what I said. If you compound interest more than just once a year, you're going to earn more money. Okay? So I know some of you are sitting out there saying, big deal, so it may be $2.43. It is a big deal. That's only $1,000 bucks. How about if you invest $100,000? You see, you can make more money by compounding interest more often. All right? So the other thing we could have done to find out at the end of the year, we could have used our formula, find the amount for $1,000 at 8% compounded quarterly by the formula or by the last quarter. When I did this, I did it by the last quarter, but we should be able to do it with our formula. So where can I write this so I don't want to mess this up? Okay, so we're starting with $1,000. 1 plus 0.08 divided by 4, raised to the 4 times a year for 1 year, right? Work it out. I always start in the middle. I don't know if that's necessarily the smartest way to do it, but what I do 0.08 divided by 4 equals plus 1 equals. Then I get what's in there. Then I raise it to the 4th power equals, and I take it times 1,000, and I get 1082.43. You get exactly the same answer as doing all that work. You need to know that formula, okay? Need to know that formula. All right. After we're done here today, some of you are going to say, what are you talking about chapter 4 being so tough? This is easy stuff. Yeah, it is. First couple sections in chapter 4 are really interesting and really easy. But then we get into logarithms, okay? All right, so let's do some problems here. Find the amount after 2 years that $5,000 is invested monthly at 6%, okay? APR, and also find the APY. Okay, so let's first do After 2 years, invested at 6% monthly. All right, so I have $5,000 is P naught, 1 plus the APR, annual percentage rate, is 0.06 divided by 12 for monthly, raised to the NM, 12 times a year times 2 years. Okay, do the work. So I have 0.06 divided by 12 equals plus 1 equals. Raise that to the 24th power, take it times 5,000, and I get 5,635.80. Okay? You invest 5,000 bucks, that's what you'll have after 2 years. All right? You can see why older folks like me, we take out certificates from a bank. It's very, very safe. You don't make a lot of interest, okay, but you do earn money on it. 2 years, it goes from 5,000 up to that. Okay? Now, what about that APY stuff? The APR, annual percentage rate, is this. The APY is the annual percentage yield. After 1 year, annual, we want to know what is the yield. We must redo this problem. Let's redo this problem. For the APY, we want to do it for 1 year. The way to remember that is annual. Annual, 1 year. Okay, let's do it again. 0.06 divided by 12 equals plus 1 equals. Raise that to the 12th. Everybody knows that when you're raising to a power, you use that little caret symbol on the calculator. Okay, so I raised that to the 12th. Now I'm going to take that times 5,000, and I get 5308.39. That means in 1 year, I have earned, watch this, everybody ready? In 1 year, I have earned $308. My yield, what I earned is $308.39. What is the annual percentage yield? Divide by 5,000. And I get 6.17%. You should always get a percentage for the APY that is slightly bigger than the APR. Now, the reason why I'm telling you this, if you go to any financial planner, if you go to any bank, go to any life insurance salesman, they will always tell you the APY. Why? Because it's a little higher than the APR. Interest rates are notoriously low right now. They want to tell you the APY. It'll make them look a little bit better. Okay, so you should understand what the APY is. There's nothing wrong with it. It's just the way it is. You are figuring out what is your yield for just 1 year, dividing by how much you put in. Okay? All right. Next, $10,000. Let's do that. Invested at 6%, so it's 1 plus 0.06 divided by, it's compounded monthly, divided by 12. Now we're doing it for 9 months. 9 months, so we're doing it monthly, which is 12. 9 months is not even a whole year. Isn't it 9 out of 12 months in a year, 9/12, which is 3/4 of a year, right? Okay, the letter N is the number of years. 9 months is 3/4 of a year. All right, calculator time. You're going to need a good calculator to do these. Okay, so I've got 0.06 divided by 12 equals plus 1 equals, okay, raised to the what power? 4 into 12 is 3 times 3 is the 9 of the 9 months. So I'm raising it to the 9th equals times 10,000, and I get 10,459.11. Okay? How about this one? 10,000 at 7%, 1.5 years compounded daily. 10,000 1 plus. It's invested at 7%, 0.07 daily, 365. Raised, and we're going to do this for 1.5 years now. Daily would be 365 times 1.5. Are you with me on that? That 365 is a little small, but you can read that. Okay? All right, so let's do the work. 0.07 divided by 365 equals plus 1 equals raised to the, what is that? I'm just going to use parentheses and put it all in. 365 times 1.5 close parentheses equals, take it times 10,000 equals, and I get 11,106.99. That's how much your investment will be worth after a year and a half. Pretty easy, huh? Okay. Okay, finally, now, mix it up a little bit. Find the present value right now. Right now, what would I have to invest? So I end up with 20,000 after 5 years. Okay, everybody get it? We don't know our starting amount, P naught. So I'm going to start here, P naught. I don't know what that is. We're going to do it 1 plus 8%, 0.08 compounded semi-annually 2. We want to do it for 5 years, so twice a year for 5 years. And we want to end up with $20,000. Yeah? So this is like an equation. We've got to find the missing variable. So start in the middle. So we'll start 0.08 divided by 2, because it's semi-annually, plus 1 equals raised to the 10th power. Yes? Okay. I get 1.48 P naught equals 20,000. So divide 20,000 divided by 1.48 is 13,513.51. You would invest this amount of money, okay, 13,513.51 right now, compounded semi-annually at 8%, you have $20,000 in 5 years. Okay? How about finding the APY? All right, let's find the APY. You're starting investing this amount. Yes? That's your P naught, starting amount. 1 plus 0.08 divided by 2 semi-annually, 1 year times 2. 1 year, I haven't switched. The letter M is here, 2. N is 1. 2 times 1 is still 2. All right, start in the middle, 0.08 divided by 2 equals, plus 1 equals, raised to the second equals, times 13,513.51 equals, and I get 14,616.21. Now, that's what I have after 1 year. Okay, now the question is, how much did it earn me? What was my yield? So I need to subtract that. Minus 13,513.51 equals, I get that in 1 year, it has earned me that amount of money divided by what you started with. Are you with me? So divided by 13,513.51 equals, and I end up with 8.16%. And remember what I said, the APY should always be slightly bigger than the APR. Got it? Okay. Homework. Very simple assignment there and should not be difficult at all.